In this video, we're going to be solving what are called oblique triangles. Oblique triangles are what we refer to as triangles that are just non-right triangles. So acute or obtuse are some examples of non-right triangles. We're actually going to use right triangle math to help us get to an equation that we can use on non-right triangle math. This equation is called the law of sines. It says that if we take ratios comparing the sine of an angle compared to the side that is opposite or across from it, we can set that equal to other corresponding ratios. If we just set up a proportion using just two of those ratios, we're not going to use all three, any two of these, then we can cross multiply, solve that proportion, and get one of the missing measurements. Either we can solve for an angle or we can solve for a side length. It's also true that we could flip the ratios and set up equations that are just upside down of that. It's really your preference as to how you like to work with the law of sines equation. But they're the same either way. So here's how we get to the law of sines. If I have triangle ABC here, a non-right triangle, I can create two right triangles inside of it by just drawing an altitude or a side length that is perpendicular to one of our sides here. And that would be the height of that oblique triangle. So now we could use right triangle math to solve for that height. And in doing so, we're going to create the law of sines here. If I wanted to solve for h using the right triangle on the right side, I could say the sine of angle C would be equal to the ratio of h over b, opposite over hypotenuse. I could solve for that opposite side by multiplying by the hypotenuse. So the sine of angle C times b would give me my h length. I could also do the exact same thing, but use the left right triangle here instead. So I could say the sine of angle B would be equal to the ratio comparing h over c, again opposite over hypotenuse. And multiplying both sides by the hypotenuse would help me solve for that h value. So c times the sine of angle B would also give me my h length. Since I have two expressions that are equivalent here, I could set them equal to each other. So ignore that h equals here and just focus on the sine of b times c equals the sine of c times b. I could then create ratios or a proportion here by dividing or undoing these terms that are being multiplied here. So if I divide both sides by c, then c is on the bottom over here. If I divide both sides by b, then b is on the bottom over on the left side. So now I've got those two ratios that are equal. I have this proportion that's most of my law of sines, and we could hopefully deduce that if this is true, then it must also be true that the sine of angle A over side A is equivalent as well. And so there is our law of sines. Again, when we use the law of sines, we're just setting up ratios comparing two opposite parts, an angle compared to the side that is opposite or across from it. So as long as we have at least that information, then we can set it equal to a ratio comparing the same corresponding parts, and we could solve for one of those unknown parts. It only works usually for certain cases. There is a case where we cannot use the law of sines, and we'll have to use something different. So we'll do that in the next video. That's called the law of cosines, and we'll be able to solve any type of non-right triangle once we have that in our toolkit. So let's just focus on law of sines here, and we'll focus on these types of triangles. I'll try and describe what that means as we do an example. All right, so we're going to do three examples here. I'm going to walk you through the first two, and then hopefully you'll know what to do on that third one, and you can try it out on your own. Given an illustration that's already labeled for us, we could talk about different ways that we label illustrations. As we saw in our equation here, angle A is represented using the capital, and side length A is represented using the lowercase version. So across from your capital letters representing angles will always be your lowercase letters representing side lengths. So one way that you could describe side EF here would be side D. It's across from angle D. And the other way to describe side ED here would be side F, across from angle F. So we're solving for angle D, that's unknown. We're solving for side F, and we're solving for side D. Those are the unknowns, and that'll help us solve this triangle. To solve for angle D, hopefully that's easy enough. That's some basic geometry. We know that all three angles in any type of triangle add up to 180 degrees. So if we know two angles already, we can just add that up, subtract from 180, and figure out our missing angle. So the sum here, 89 and 30, take that away from 180, and we're left with 61 degrees for angle D. So now that we have angle D, we can solve for side length D. We're going to do that by setting it equal to our ratio comparing angle E and side E. So those two given informations right there are going to help us solve for some unknown information elsewhere on the triangle. So here's my starting proportion. Substitute what I know. Angle E is 89, side E is 40 units. Setting that equal to sine of angle D, which is 61. We solved for that. And that's on top of side D, which we don't know. We're going to cross multiply to solve the proportion. So D times the sine of 89 degrees should be equal to the other cross product, 40 times sine of 61. To solve for D, we're going to undo that multiplication and divide both sides by sine of 89. So you can do this all on your calculator in one step. Be careful with your parentheses. Or you could just do it using two steps here. 40 times the sine of 61, and then divide that by the sine of 89. Ooh, one thing I forgot. Hopefully you saw it up here. We're in degree mode for this video. Now that we're actually plugging things into our calculator, if you're getting some weird numbers, check your mode and set it to degree mode in case you're not there. All right, so again, this quotient here should give us our answer for side D, which is about 35 if we round. So EF for side D there is 35 units long. To solve for ED, I'm going to go ahead and start the exact same way. Using angle E and side E, that ratio that I already know the given information for. And I'm going to set that equal to the ratio comparing angle F to side F. And just for fun, I'm going to flip my ratios just to show you that it doesn't matter. So side E is going to go on top here, 40, and sine of angle E or sine of 89 is on the bottom. Just make sure in your next ratio that you match whatever you did in your first ratio. Put the side length side F on top, it's unknown, and sine of my angle F or sine of 30 on the bottom. Cross multiplying says that we're going to have F times sine of 89 equal to 40 times sine of 30. I can divide both sides by the sine of 89 to get my side length F, and we get about 20. So this triangle could be described as an angle-side triangle with the given information of angle E, angle F, and side E. Notice that the side is not in between the two angles, it's outside the two angles. So that's angle, side. So anytime you see anything similar to that with the given information of a non-right triangle, you know that law of sines is going to work. Again, because we see that we have an angle across from a side that's given to us, and we're given at least another angle or another side to work with. All right, just to step it up on this next example, instead of being given the diagram, we're just going to be given some information. So it's up to us to sketch out the triangle with the given information and then solve. So given triangle ABC, those are the angles in my triangle. It doesn't matter where I put A, B, and C as long as I make them consecutive, one after the other. I can't say, I could say B, C, A. Yeah, it doesn't really matter. I don't think there's any way that you can mess it up. As long as you substitute your information into the triangle, then we should be all good. So angle C is 25 degrees. B, side B is 23. Side B is going to be across from angle B. So wherever you put your angle B, put 23 on the side across from that. Side C is 26. Again, that's going to be across from angle C. So wherever you put angle C, 26 should be across from it. Also, it's probably not going to be a triangle that's drawn to scale. Don't worry about that. It's just going to be a generic drawing. If you are really serious about drawing at least triangles that may look halfway decent, well, then you may have to resketch after solving some of the measures. All right, so let's see what we got. What pair do we know here? We have angle C and side C. That's the information that we're given. So we're going to use that as one of our ratios in our equation. Sine of 25 over side 26 length. And I'm going to set that equal to another pair of corresponding parts. So because I know side B, then I'm going to be able to solve for angle B. All right, so set up sine of B over side length B of 23. And now we can cross multiply to solve. We're going to do 26 times sine of B, set that equal to 23 times the sine of 25. We'll divide both sides by 26. Notice that that doesn't solve for B, or angle B here. That is going to be a ratio representing the value of the sine of angle B, and we can solve for B by doing the inverse of sine. You could do the inverse sine of this mess right here, or you could simplify that down to a decimal form. Try and include at least 3 or 4 decimal points to be as accurate as possible. And then you could inverse sine both sides. So the inverse sine is going to give us the measure of our angle, and it's about 22 degrees. Now that we know angle B and we know angle C, we could use the definition of angles in a triangle to solve for angle A, add up what we know and subtract from 180, and we get 133 degrees. So there's angle A. So notice angle A I drew as an acute angle, and then I figured out that its measure was 133 degrees. That's an obtuse angle, so if it really bothers you and you want to redraw your sketch, then maybe it should look more like that. But to be honest, it's not necessary to solve and get the answers correct. All right, last thing to do is solve for side A. Again, I'm going to use the pair that I know, sine of angle C compared to side C. And now I'm going to set that equal to sine of angle A, which I now know is 133 degrees, compared to side A, which we'll solve for. Cross multiplying here, 26 times the sine of 133, and then dividing by the sine of 25. Notice I kind of skipped that middle step now that I'm getting comfy here. Do this all on your calculator, or take it one step at a time, and you should get a side length of about 45 units. All right, so you got one more here to do. Again, you're going to have to sketch out the triangle and solve for the unknown pieces. Go ahead and set it up and see what you can do, and then unpause the video for the answer. All right, so how'd you do? Angle F should be about 34 degrees. I solved for angle F after I solved for angle D. So here my work shown if you did that. I solved for angle D. Maybe you solved for angle F first and then did similar steps to solve for angle D. That's okay. As long as we have the same answer, you could be certain that your steps were probably accurate. And then lastly, to solve for side F, here's my work shown there, and we get about 10. All right, so there's part one, using the law of sines to solve for measures in an oblique or non-right triangle. We saw examples of angle, angle, side, and side, side, angle. There wasn't any angle side angle examples in there, but angle side angle is going to be very similar to the angle angle side. You know two angles and you're given a side. So the technique and methods and steps will be very similar to this example. So in the next video, we'll see how we can work with that last type of triangle, that side angle side example, and we'll use what's called the law of cosines. So practice the law of sines because we got more coming.